Cross-elasticity of demand measures the responsiveness of consumer demand for one good to a change in the price of another good. The demand for many goods is determined not only by the price of the product in question, but also by the change in the prices of other, related goods. XED helps clarify the exact nature of these relationships. The equation to calculate the coefficient of cross-elasticity is XED equals the percentage change in quantity demanded for good A over the percentage change in the price of good B. For example, if, as a result of a 10% increase in the price of Pepsi Cola, the demand for Coca-Cola increases by 25%, then the cross-elasticity of Pepsi with respect to Coca-Cola is plus 2.5. This is a positive value. As the price of Pepsi rises, the demand for Coca-Cola, a substitute, also rises. Cross-elasticity can also have a negative value. For example, if the demand for motor vehicles falls by 2% following a 20% rise in the price of motor insurance, the XED of motor vehicles with respect to motor insurance is minus 0.1. Goods are identified as complementary goods when the coefficient of cross-elasticity is negative and as substitutes when the relationship is positive. However, there is another aspect to cross-elasticity, exactly how responsive, that is, how elastic, the demand for one good is to a change in the price of another one. Economists use the concept of proportionate to assess the degree of response. For example, if the demand for one product changes in the same proportion as the price of another one, then the result is proportionate and XED will equal 1. If it does, then cross-elasticity is said to be unitary. When the coefficient is less than 1, the cross-elasticity is inelastic, and when it is greater than 1, it is elastic. So, in the case of Pepsi and Coke, the XED is elastic at plus 2.5, which means that Pepsi and Coke are considered fairly close substitutes. The greater the coefficient, the closer the substitute, so that if the cross-elasticity is positive and infinite, the goods are perfect substitutes. In the case of motor vehicles and motor insurance, while the negative coefficient indicates the goods are complements, the low value, at minus 0.1, indicates that the response is much less than proportionate, suggesting that changes in motor insurance premiums have a relatively small impact on the demand for vehicles. Firms are interested in calculating cross-elasticity because it helps them map out their market to discover who their competitors are and how significant they are, as well as identifying significant complementary products. For example, if a motor manufacturer estimates that one of its models has a cross-elasticity of plus 2.0 with respect to a similar model produced by a competitor, then any drop in price by the rival will have a greater than proportionate effect on the quantity demanded of its car. This makes the firm vulnerable to competition on price. For example, assuming the XED for two substitute motor cars is plus 2.0, a reduction in the price of one by 5% will lead to a 10% reduction in demand for the other. In markets with few competitors, cross-elasticity between rivals is likely to be very high. In the case of complements, the degree of cross-elasticity indicates the extent to which the goods are in joint demand. Goods are in joint demand when the purchase and use of one good requires that another good is also purchased, such as a torch requiring a battery. In this case, a firm is vulnerable to a price rise of a complementary good. If batteries rise in price, fewer torches may be sold. In many situations, firms can gain more control over their market by merging with competitors or with suppliers of complementary products, or indeed, they may develop their own complementary products, such as Google developing its own smartphone, the Pixel. Clearly, information on cross-elasticity is very useful in that it helps firms gain a deeper understanding of their market, enabling them to make more rational decisions about the best way to allocate their scarce resources and to maximize profits. However, there is a word of caution. Like all elasticities, cross-elasticity values are not fixed and can vary considerably between groups of consumers and over time. This means that business decisions based on historical cross-elasticity estimates may be subject to information failure. For this reason, data on cross-elasticity on its own will not provide sufficient information to make rational business. Income elasticity of demand measures the responsiveness of consumer demand to a change in income. The equation to calculate the coefficient of YED is YED equals the percentage change in quantity demanded over the percentage change in income. For example, If income rises by 5% in a year, and the demand for clothing increases by 10%, then the YED for clothing is plus 2.0. The result is a positive one. As income rises, so does the demand for clothing, in this case by a greater proportion than the increase in income. However, if demand for bread falls by 20% following an increase in income of 5%, the YED for bread over the relevant income range is -4. In the case of bread, the result is a negative one. Goods where the relationship is positive are called normal goods, and inferior when the relationship is inverse. However, there is another aspect to income elasticity, exactly how responsive, that is, how elastic, demand is to a change in income. Economists use the concept of proportionate to compare responses. For example, if the demand for a product changes in exactly the same proportion as income changes, then the result is proportionate, and YED will equal 1. If it does, then YED is said to be unitary. When the coefficient is less than 1, the YED is inelastic, and when it is greater than 1, it is elastic. So, in the case of both clothing and bread, YED is elastic, which means there is a greater proportionate response in demand to the change in income. Both goods are elastic, despite having different signs. It is therefore possible to have both elastic and inelastic normal and inferior goods. For example, if the YED is plus 2.5 for smartphones and is minus 0.5 for rice, then we can deduce the smartphones are, with respect to income, an elastically demanded normal good, and rice is an inelastically demanded inferior good. Income elasticity can be visualized through Engel curves. Here we can see that Engel curve A slopes upwards, and it is steep, which indicates that the quantity demanded for good A changes by a smaller proportion than income, indicating that it is a normal good with an inelastic YED. Engel curve B also slopes upward, indicating it is a normal good, but the gradient is much flatter, indicating that the quantity demanded of good B changes by a greater proportion than income, hence YED is elastic. In this case, the good is not only normal, but is considered to be a luxury good. Finally, with Engel curve C, the gradient is downward sloping, indicating that the relationship between income and quantity demanded is inverse, and the good is an inferior good. Economists are interested in income elasticity because knowing YED helps firms and governments plan their output in such a way that they can respond effectively to demand changes and achieve an efficient use of scarce resources. For example, if a US firm produces a product to be sold in 2 countries, Germany and Japan, and its market research suggests that the YED in Germany is 2.2 and in Japan is 0.5, then the firm can predict sales following changes in consumer incomes in Germany and Japan. For example, if incomes are forecast to rise by 4% in Germany and by only 2% in Japan, then demand in Germany will increase by 8.8% and in Japan by only 1%. This is highly significant, and the firm can target more resources to the growing market in Germany. Similarly, governments will take into account YED for public goods and merit goods. For example, if the YED for motor vehicles is 3.5 and for cycles is 0.2, then, as national income grows, demand for road space will grow, with demands for roads increasing more than for cycle lanes. Using these figures, we can predict that an increase in a country's income of 2% will lead to a 7% increase in demand for motor vehicles, and just a 0.4% increase in demand for cycles. This information, along with YED data for a whole range of transport forms, can help shape a government's transport policy. Clearly, information on YED is very useful in that it helps solve the problem of information failure and enables firms and governments to make more rational decisions about the best way to allocate scarce resources to competing uses.